In this video, let me demonstrate to you how to use your Android smartphone to make it as a powerful oscilloscope into a real bench test of a Class A power amplifier, signal analysis of sine wave and square wave. Alright guys, stick around to this video till the end and let's go for that. Alright guys, welcome once again to the screen of my Android smartphone, the Honor 70. And let me dive to introduce to you about these two signals right now. So the upper signal is the input signal, which is, I can read the RMS value right here, a little bit small. I don't think you can see that. Let me use the mouse cursor. So this is the mouse cursor, you can see that. Currently, it is about 0.14, that is 140 millivolt RMS. And this signal in here is 0 right now because the Class A power amplifier is still turned off. And if I'm going to turn it on right now, there you go. It's rising up, it's rising up. So this is the voltage swing at the 4 ohms resistive load. And currently the RMS value right now is 1.18 volt RMS. Again, this is the voltage swing at the 4 ohms resistive load. And in order for me to work properly, I would like to have the 1 watt power output at the 4 ohms resistive load. That would be a good power for me to work it on with the Android smartphone turning into a powerful oscilloscope. What I have to do then is this voltage swing, put that into 2.1 volt RMS, and I need to increase the AF generator right now. This is an external AF generator. You can see that it is increasing, and increasing. And now I got 2.09, 2.13. So it's overlap already on the screen, and that is not good. What I can do is to click this I in here, which is just like how you see it, and click that one, and it fits in right now. And another thing that I'd like to mention is that if you don't like this screen right now, you can actually select the I would say what happened in there. There you go. The input signal in the yellow and the output in the green, and you can see that it's 180 out of phase. All right. Now I just wanted to see this one because this is my favorite, because I can actually separate them. And what I would like to mention right now is that with about 1 watt output power, again, this voltage swing at the 4 ohms resistive load, that is 2.13. That is almost equivalent to 1 watt output power. And now the input is about, I can read it to be like 280 millivolt RMS. That's it. And I think this is self-explanatory already, that I mentioned also last time, that the output signal, this is 1 cycle and it is being shaded, and that is where they're taking the RMS value in here. This is the RMS value. That's the peak to peak value. I think I can able to shake like this also using the mouse. I attach the mouse in the mobile phone so that I can access it easily instead of my finger. The finger is a little bit naughty, that I don't have to explain about that one, but the mouse is perfectly doing its best to doing all the selection, like this selection in here, and making the signal to be much better. You can see the time base, like don't touch that one. Say 300 microsecond. Let's just say also 500 microsecond, which is absolutely nice if you have a mouse rather than your finger like that. But of course, it's possible that you can have your finger as well. Is a good to use a touch screen, like a touch at a touch screen. But if you have a naughty finger, that's something different. All you have to do then is just click this one and then go to it, and it will display to you the best signal that will fit into your screen. And this signal actually is being mirrored in my oscilloscope, the stand-alone oscilloscope. Want to make sure that what I'm reading in here, they are exactly the same or very close to what I'm reading in my original oscilloscope. Which means to say that it's a kind of qualifications. The upper one is the input and the lower one is the output. And this is my setup, by the way. This is why I normally talk my what I call a sound profile gala. There it goes. Let's focus on this smartphone, Android smartphone, turning into a powerful oscilloscope. All right, guys, this is the most interesting part wherein we're going to know the maximum voltage swing at the resistive load, wherein there is no distortion meter. Again, in order for me to correctly understand about distortion and the maximum power output, I should estimate that the peaks of this voltage swing at the resistive load, there will be no much clipping. There will be no much clipping in here. So let's do that. I'm going to increase now the input signal until it clipping. You can see in here already. So this is clipping to me already, and that is significant distortion wherein it is unacceptable. And it is also clipping in there. If you can see that one, the lower signal is also clipping, and that is why this is already unacceptable. So I'm going to decrease the input signal right now. I think that is the best for me as a complete signal. And let me read what is the RMS value right now. This is channel B, and let me put that into a better roller. Okay, so it's about 3.77 volt RMS. This is the maximum voltage swing to my judgment. Let me see if I'm going to increase again. I think 3.97 is the one maximum. Say 3.91. Let's just say 3.91 to be acceptable to me. Yes, there you go. From here, that is a 3.91 volt RMS. So this is the maximum voltage swing at the forum's resistive load at an acceptable level of approximate distortion. I'm saying again that THD is not available in here, so I just approximate it. All right, that's it. And that's the maximum voltage swing. Going back to a minimum signal, and then going to increase that again. Let's see the distortion in there. You can see the distortion. Let me remove the roller in there. So there you go. Very clean. One thing that I would like to do in here is that I wanted to capture the signal and share it to you guys, anyone who is interested. So I'm going to do a kind of signal acquisition. That is the signal acquisition in here in PDF, and I want to share it in WeChat. That's it. Share it in WeChat. And why I have two? Oh yes, I have two WeChat in here. I know this one is for the secret one, and this one is the normal one. So I'm going to use the secret one, and then it goes to this guy in here, and then I just say share. And then share. Stay in Weixin. No, I don't like to stay in Weixin, so I go back to the original signals in here. Oops, it did not go. Oh my god, it did not go. It's showing my secret right now. So again, this is the oscilloscope. What happened to my Weixin? Let me take a look at it. Yes, something sent to me in here, and I'll show you later. I need to go and reverse the camera. Pass is the channel 1, which is the input signal, and we can see in here about 0.54 volt RMS. Here, that is about 540 millivolt RMS. And let's see that. And I'm going to switch now into square wave. And there you go. So the volt RMS of the square wave at 1 kilohertz is 2.15. That's still about 1 watt of power. This is the input. Is still at about 280 millivolt RMS at 1 kilohertz. Let's remember this signal at 1 kilohertz. You can see it's 1 kilohertz in here. And if I'm going to switch that to 10 kilohertz, that's gonna be the signal. You can see this one is 9.926 kilohertz, and it is really dense, and I'd like to expand that one. I'd like to show you. I'm using my naughty finger right now, so there you go. I'm expanding now. Don't worry about the one. You can always fix that with the eye, and there you go. I can still expand it like there you go. Okay, there you go. Yeah, you can actually use your finger to fix it. I moved the phone and like to put the one into center. Sorry for that. Use the eye. The eye is in here, so that much better right now. And still almost like a perfect square in here. You can actually go deeper. There you go. Let me do that in the storage mode. So just click this one, stop it, and then it now goes into the storage mode. And you can see in here, there you go. Still almost perfect at 10 kilohertz. And if you're going to see what's the signal at 400 hertz, I'm going to play that. It goes back to the original signal, better viewing angle, and then goes to 400 hertz. That is 1 kilohertz and 400 hertz. Using your naughty finger, you can adjust that one. All right, that's much better right now. My intention is that as you can see in here, there is a frequency loss in the low frequency in here. This one is slanting, and that needs to be measured. So that's the reason why I'm using the cursor right now. So this one, I put it right here, and the other one, I put it at the top of the square wave, and it gives you about the difference of about 0.261. This is the difference in here. 1.83 at the top and minus 2.09. That is a minus 1.83 at this top and minus 2.09. Give you a delta of about 0.261, which is that is in volts, and that can be converted into dV basically using some formulas, which is outside of this video. And this is a signal analysis in the square wave at 400 hertz. No, not 400 hertz. This is, I'm messing up right now, guys. I'm messing up right now. So let's measure it. What's the hertz in here? So I'm going to measure the one in there. So start from the signal. That is the start of the signal and complete a one cycle. So I'm messing up, and to complete that one, we'll see to be here at about 100 hertz. So now this is 100 hertz, not a 400 hertz then. And probably I can go down to 20 hertz. So 20 hertz. There you go. Oh my god, it's power off. The mobile phone is power off. Oh my god. This is my other phone, which is Samsung. We got 100% right now. I can use it while I'm charging the other phone in here. Have to charge it. Not good, not good. So this is the Honor, your Honor, and this is Samsung, which is smaller. You see, my Honor did not stand my working demonstration. It's a Galaxy S8, and I'm going to use that one to continue my demonstration using the Android smartphone and the OSC482H. I almost forgot the H. I got the Aquarius signal ready, and what I can do is to froze it into the storage mode. This is live one, and I can froze the one in here. Look at the top right corner, froze that. And what I do is in here, I don't need the input signal actually. I'm going to use this cursor in here to put at the top left corner, which is the starting of the square wave signal, and also at the top right corner the waveform. And there you go, you got about a change of 0.494 volt. What I'm going to do right now is to understand what is the frequency of this signal in here, wherein I can invoke this cursor in here, and I put that into the start of the signal, that is the output signal, and get another cursor and put that into the end of this cycle. So this is one cycle actually. And where is that cursor? Did I miss that one? There it goes, and it goes away. So I'm going to compress once more to be like that. There you go, so that I can emphasize the other cursor in here. So there you go. All right, so the frequency is about in here, the frequency in here, which is about 20.29 hertz. So basically that is at the low end frequency of the audio spectrum, with the signal is heavily attenuated to about 0.494 volts. A quick tour of the setup. Let me show you the main actor in here. This is a Class A power amplifier, which is the ACA amp camp amp from Taobao Market. And the source of power is this DC power supply set it to 20 volts with 1.604 amperes being consumed right now. This is power to the Class A power amplifier, and the resistive load, which is about 4.18 ohms. And then the input signal is from the EF generator, currently at 1 kilohertz sine wave in here. And then the input is also monitored by the OSC482. This one in here is a sine wave, and also from the old oscilloscope, just to make it sure that the reading on the smartphone is closely to the reading of the O1 oscilloscope, which is currently true. So far so good. And then the output, the voltage swing, is monitored both the old oscilloscope and the smartphone Android phone oscilloscope, which is basically the same, I would say, right now. Of course, the OSC482 oscilloscope, the USB is connected to the Android smartphone. And I'm using a hub in here, wherein I have a USB wireless mouse so that I can access it nicely instead of my finger. I think that's it for the whole setup in terms of the equipment. But I have added in here a temperature sensor, which is a K-type sensor hooked into the top or the tab of the power transistors, the MOSFET power transistor. What I can read right now is 70 degrees centigrade in here. And another one here at the UT71E. This is the K-type sensor with this reading about, oops, that's not intentional, I should say. It is reading about 89.2 degrees centigrade. Very, very close between this one and this one. And finally, my setup is not complete without my Nathan boy favorite toy. He gave me this one so that whenever I make a demo, he will always be included in that, even though he's not physically in here. because he's now in school and he cannot attend this video demonstration. And the other one is in there, which is the blue one. Used to be that he liked the yellow one, like the color of the bumblebee, and that should be for me. We're planning that it's when the time that he can drive the motorbike, this yellow one in here, we can go for a kind of fun riding somewhere along the beach. I think that is the end of the demonstration right now. Wherein I think it's enough to demonstrate what's the capability of the smartphone, Android smartphone, when it turns into a powerful smartphone oscilloscope with the OSC482H.